Alright, question 10. A learner placed 200 grams of calcium carbonate into a conical flask and added 500 cubic centimeter of a 1.5 molar dilute hydrochloric acid solution. What would remain in the flask at the end of the chemical reaction? Want to determine what is going to remain. All we are determining is what will be the excess reagent, right? So what you have is calcium carbonate reacting with hydrochloric acid. Every time an acid reacts with a carbonate, you are going to form a salt, carbon dioxide, and water. So when calcium is going to take up the chlorine, so we are going to have calcium chloride. Now calcium is in group 2 of the periodic table, meaning that the valence is 2. It loses 2 electrons. Chlorine is in group 7, so it gains 1 electron. That's a valence of 1. So valence can just be the number of electrons which are either going to be gained or lost by an atom. So the 2 which is on the calcium is going to come on the chlorine, the one on the chlorine is going to come on the calcium. So what you are going to have, the formula for calcium chloride, there is CaCl with a 2 down there, because even when I put a 1 here, it doesn't make any difference. So calcium chloride plus carbon dioxide plus water. These are the products. So every time you have got an acid reacting with a carbonate, you should always have a salt, calcium chloride, carbon dioxide, and water. Now from here we've been told that 200 grams of calcium carbonate reacts. It reacts with what? 1.5 molar and then 500 cubic centimeters uh, of hydrochloric acid. Make sure that this reaction is balanced, because you can't work with chemistry if reactions are not balanced. So you can see for chlorine, you have got 2 of them here, meaning that for me to balance, I'm also going to put a 2 in front here. If I put a 2 in front there, I'll make the hydrogens 2. Also the hydrogens on the products are 2. So the reaction is now balanced like that. So what you do is you're going to calculate the number of moles of calcium carbonate. You also calculate the number of moles of hydrochloric acid. And then the one which has got small number is going to be the one which is limiting. Okay. So number of moles of calcium carbonate. How do you find number of moles? What's the formula?
Number of moles.
Mm.
Yeah, K mass over molar mass.
Mass over molar mass. Good. So mass over molar mass. So the mass of calcium carbonate is already given, that is 200. Just use the value given on given. It should be always in grams. Molar mass. So to find the molar mass, you use the periodic table. So you do this. You have got 3 oxygens on the periodic table. The mass of oxygen is 16. And then you have got carbon. It's only 1. The mass on the periodic table for carbon is 12. And then you have got calcium. It is only 1. The mass on the periodic table is 40. 3 times 16 is it 48 plus 12 60 plus 40 100. So that is going to be 100 grams per mole. So divide by 100. Molar mass is given in grams per mole. So a gram theologically cancel. So the answer is going to be 2 moles. Okay, and then we find the number of moles of hydrochloric acid. Now, for hydrochloric acid, we've been given concentration and volume. So to find the number of moles, you will not use mass over molar mass, because we don't know the mass, we don't know the molar mass. So number of moles is concentration times volume. So that's what we are going to use. Concentration we have is 1.5 molar. Okay. Now if you hear of 1.5 molar, molar M, capital M, means mole per decimeter cubed or mole per liter. So we're going to multiply this now by the volume. The volume is 500 cubic centimeter. Now, you want your answer to be in moles. If you look at this, you have got a decimeter cubed down, you have got a centimeter cubed here. You can't cancel those. So what you do is you are going to convert the cubic centimeter to meters, I mean to cubic decimeter. So how do you do that? So this, just multiply, okay? You multiply. You can see you have got a cubic centimeter here. So I want to cancel the cubic centimeter. So I'm going to put a cubic centimeter down. I want to go to a cubic decimeter, so I'm going to put a cubic decimeter here. In 1 cubic decimeter, we have got 1000, which is the same as 10 to the power 3 cubic centimeters. So this cubic centimeter will cancel this cubic centimeter, this decimeter cubed will cancel this decimeter cubed. So this is how you get to convert. In other words, when you are converting, maybe something that you just need to know, when you are converting from centimeters cubed to decimeter cubed, this answer which is in centimeter cubed, just divide it by 1000 and then you are going to go to decimeter cubed. So if you have got answer in decimeter cubed, multiply it by 1000, you are going to go to centimeter cubed. Is that okay?
Yes.
Okay. So just do the multiplication here. 1000 into 500 is going to give you 0.5. So what you do is 1.5 times 0.5, that is going to give us 0.75. Now remember the hydrochloric acid had a 2 in front, right? So what you do is number of moles of hydrochloric acid. So you have found 0.75. Now, when you want to see which one is the limiting reagent, you need to take note of the balance reaction. Otherwise, if you don't consider a balance reaction, you are going to get a wrong value. Okay? You get a wrong value. So, how do you now determine which one is the limiting reagent, which one is the excise reagent? Since hydrochloric acid had a 2 in front, the answer that you have found divided by 2. Okay, divided by 2. So that is going to give you 0.375 moles. So you always divide by the number that you have that is in front. So number of moles is given by mass over molar mass. And then let's say nga kwachiba 3 kuntansho could have also divided by 3 down here. So this one, since there is a 2 in front, we've divided by a 2. That's the 2 that you've seen I've written down here. So now consider which one is big, 2 or 0.375. So 2 is big, meaning that calcium carbonate is in excess, is going to remain. Okay, so from the options, calcium chloride and water only, aqueous calcium hydroxide only, calcium carbonate and calcium hydroxide, calcium carbonate, aqueous calcium hydroxide and water, calcium carbonate, aqueous calcium chloride and water. So what is going to happen is this calcium carbonate you are seeing here is going to remain. This hydrochloric acid is going to finish, but also the products, these products you are seeing, you are also going to have them. So you're also going to have calcium chloride, carbon dioxide, and the water. So these are the ones which you are going to see in what? In excess. Water, carbon dioxide, calcium chloride, and calcium carbonate. So what will be the answer? Calcium carbonate, aqueous calcium chloride and water. This is true. Calcium carbonate, aqueous calcium hydroxide. We don't have calcium hydroxide as a product, so this is wrong. Aqueous calcium hydroxide. Calcium hydroxide is also wrong. Calcium chloride and water only. It is not this only, so that is also wrong. Have you gotten it now?
Yeah. Noma lwakibonera kumukwipisha wasanga.
Mm,
Imwe kishita concentration times.
mm.
Ndipo mwilongo kishita concentration times.
Okay. Concentration times volume. So you need to know. when you are finding number of moles, I mean concentration. Concentration is given as number of moles over volume. Do you know this equation?
naibuka but tishakuibunja formula.
Mm-hmm. So if you want to find the concentration, just divide by the number of moles over volume. So meaning that if you make number of moles up to the formula, you just multiply concentration by volume. So that's where it comes from. Okay.
Yeah, okay, okay, thank you.
Okay. We'll see how much more to use it as you get to fit different questions. Okay, question 11. Solution Q reacted with aqueous sodium hydroxide producing a gas which changed the color of red litmus paper. Which of the following could have been solution Q? Now, what you've been told is solution Q reacted with aqueous sodium hydroxide. Aqueous sodium hydroxide. So sodium hydroxide is like this. Do you know what an acid is? Acids and bases.
Ulifaa kukubelenga po. Ona ulivyokubelenga malawi.
Okay. So an acid is a compound that has got an hydrogen. Okay. If you see a compound like HCl, H2Cl4, H F, all these are acids. They've got hydrogen ion. Hydrogen ion. So when they dissociate, they are going to have hydrogen ion and chlorine ion. This one dissociates, is going to have two hydrogen ions and the sulfate ion. This one dissociates, is going to have hydrogen ions and the fluorine ion. So an acid always has got an hydrogen ion when it dissociates. Now a base is a compound that reacts with an acid to form a salt. So mostly for bases, when you see hydroxide OH, then that's a base. Is that okay?
Yes.
So what happens is that when an acid reacts with a base, you are going to form salt and water. Remember, a base has got OH. Acid has got H. So for example, HCl, this is an acid. And then you have got sodium hydroxide. This is a base. So this hydrogen of the acid will react with the hydroxide of the base to form water. And then now the sodium is going to react with the chlorine to form the salt, sodium chloride. Actually, so the salt you use, table salt, is sodium chloride. So this is an acid-base reaction. Now here you've been told that solution Q reacted with sodium hydroxide. So what is sodium hydroxide? Is it an acid or a base?
Best.
It's a base. Now we've been told that Q reacted with sodium hydroxide, producing a gas which changed producing a gas which changed the color of the litmus paper. So if this produced a gas, you need again to know this. When, let me just mention them. I've told you about acid and a base. When an acid reacts with a base, you are going to form salt and water. This you need to know. Another thing, now, when a metal reacts with a base, you are going to form a salt and what are going to form. This one's then supposed to be a metal and a base. It's actually a metal and an acid. You are going to form a salt and also hydrogen. Now, when you have got an acid and a carbonate, this is like the previous question. You are going to form a salt, carbon dioxide, and water. These are some things that you can know because they'll come. Those reactions are going to be brought to see if you can write the product.
acid na carbonate which to produce salt water and what?
Salt water and carbon dioxide. Okay, so from here you've been told that when Q reacts with sodium hydroxide, it's supposed to produce a gas. A gas. Now, just look at at the reactants which have been given. You see which one is going to produce a gas. I think that can help us to identify. If you look at ammonium sulfate, you should be able to write the formulas of these compounds. You need to know how to write the formulas of this compound. So ammonium comes from ammonia. Ammonia is NH3. Now, if you hear of ammonium, you have got four hydrogens, okay? And this thing has got a charge of positive one. That's ammonium, it's an ion. Sulfate, a sulfate is SO with a 4 down. This thing has a charge of 4, negative 2. So ammonium sulfate, now you combine these two. So I've got ammonium. This two which is on the sulfate is going to come down the ammonium. And then the one on the ammonium is going to go on the sulfate. So this is going to be the compound. Now, for the sulfate, I'm not going to put it in brackets because when a one goes down the sulfate, it doesn't change anything. So this is what you are going to have, ammonium sulfate. Now, ammonium sulfate is a salt. Okay, and then if you look at calcium sulfate, this is written like this, calcium sulfate like that. And then you have got potassium sulfate, potassium sulfate like that. And then you have got sodium sulfate. Okay, this is what you have. Now, which of the following could have been solution Q? So, which of these is able to react with sodium hydroxide? Remember, sodium hydroxide is a base. So, you want something, and actually, these things which you're able to see here are salts. Okay, so you want at least something which has got hydrogen. You know I should have hydrogen because hydrogen changes a litmus paper, a red litmus paper. Hydrogen is a characteristic of an acid. Remember what I said? If they say what gives an acid its characteristic or what gives the acid a sour taste, it is hydrogen ion. Okay, so a base is going to change a red litmus paper to blue. BRB, this should help you. Like they can ask sometimes. A base changes a red litmus paper to blue, meaning that an acid changes a blue litmus paper red. You get that?
Yes, yeah, now.
Base changes red litmus paper blue, and then acid changes blue litmus paper red. Now, what is this one saying? A gas which changed the color of a red litmus paper. So a gas which changed the color of the red litmus paper, meaning that that gas should be what? If you change the color of a red litmus paper, what do you think that gas should be? Should it be a base or an acid?
Yes.
It should be a base. Okay, good. So now you want to look at all these. You see which one is going to give us a base as a certain product. Now, basically, the calcium is a metal, potassium is also a metal, sodium is also a metal. So these three, they can't give us that. Now ammonia itself, ammonia is a base. So this gas is a base. This gas is going to be produced in this reaction. That's why you are going to have the change of a red litmus paper. So that is how you analyze these questions. Because questions are not going to come out that direct. What they want you to do is just apply knowledge you know. Okay? Just the knowledge you know. Ammonia is a base. Ammonia is a base. That is why it gets to change a red litmus paper. That's okay? A. That's the answer. Okay, let's go to question 12. Salts can be classified as acidic, basic, or neutral. Which of the following is a pair of basic salts? Now, remember, how do you form a salt? You just get to react an acid and a base, or you can react an acid with a metal, or you can react an acid with a carbonate. Now, if you have got a salt that is made up of, that is coming like from acids, that is what we call an acidic salt. Okay, which is coming from bases, that's a basic salt. And then a neutral is one that is just coming from an equal amount of acid and base, like that. I don't know if you can get that. So you have got an acidic salt, a basic salt, and a neutral salt, depending with where it is coming from, like the reactants which you use. So a basic salt is a type of salt formed due to a reaction of a weak acid and a strong base. That's why we are calling it basic. You are using a strong base, like a very strong base, and a weak acid. Now, examples. So here we also need to know what are weak acid and strong acids. So an example of a weak acid. Let me first state strong acids you need to know. Hydrochloric acid is a strong acid. Sulfuric acid is a strong acid. So you need to know these two at least. Also, nitric acid is a strong acid. This one. These are strong acids. Yeah. Now, when you're talking about weak acids, weak acids come from things like carbonates. So when you say carbonates, that's a weak acid. So look at this. Here you have got a chlorine. Where do you think chlorine is coming from? It's coming from the hydrochloric acid, which is a strong acid, meaning that this is an acidic salt, it's not a basic salt. You get that?
So na D ya papa di ammonia
Uh-huh. Even this one, huh?
na D Alaska.
Okay. Even this one is also wrong. So you can easily tell that the answer is going to be this one.
Yes, yeah.
Yeah, that's how you get to find that. You see, just applying just to the things that you know. So let's consider 13. A bee sting is acidic. Which household substance would neutralize a bee sting? Now, if you want to you remember a bee sting is acidic. So the thing that you are looking for to neutralize a bee sting should be basic. Okay, should be basic. Now, of these, the question is which one is basic? Bicarbonate. Bicarbonate is soda. Is soda basic or acidic? That's the question. And then you have got common salt. Common salt, this is a salt. It's not acidic, it's not basic. It's a combination. And then juice, lemon juice. Do you think it's an acid or a base?
Acid,
It's acidic. So this one also can't be the answer. Okay. Vinegar. Do you think vinegar is an acid or a base?
acid,
It's an acid. It can't be the answer. So soda is a base. Bicarbonate, it is written like this, HCO3 minus. This is a base. So that's the one which is going to neutralize. Question 14. Choose a statement that is most likely to be true about the element in group who. What group is this?
8,
Group
no
8.
Bogart.
What do we call group 8 uh, elements?
No Bogatis.
Noble gases or inert gases. What of group 7?
Group 7 not sure.
Halogens. And then group 1, alkaline metals. Group 2, alkaline earth metals. Okay, periodic table is like this. And then you have got these ones which are here. What do we call them?
Transition metal.
Transition metals. So that is it. So, uh, What would be true about elements in group 8 of the periodic table? They are equally reactive chemically. Are group 8 elements reactive?
Uh,
That's why we call them noble gases or innate. Innate means not reactive. They form oxides of similar formula. These don't form oxides. Like they don't react. How can they form oxides? Occur, occur and combined in nature. This is true. They occur and combined. For example, helium, okay, neon. It's not like oxygen which occurs combined, hydrogen which occurs combined. No, they're not like that. Becomes less metallic as atomic number increases. They're actually not metallic, so they can't become less metallic. So the answer is C. We are good.
yes, yes.
Okay, 15. Which of the following statement is correct about alloys? What is an alloy? What is an alloy? An alloy is a mixture of metals. For example, when you get to mix, uh, you mix iron with, let's say, some other element. You mix one metal with another. Okay, the aim is to make those metals to be much stronger. For example, iron alone, you know that iron rusts, huh? You know rusting in Dalawa. Okay, so this one gets to rust very fast. So if you want to make it so strong, you're going to react it with other elements like chromium. So when you react it like that, you are going to form what we call steel. And the steel is strong and it can't be easily rusted. Is that okay?
Yes.
Okay. So that those are just some functions of alloying metals. So uh, which of the following statement is true about alloys? They are mixtures made up of metals and other substances. Now, other substances, let me put a dot there. Compounds made up of metals and other substances. Let me put also a dot there. Metals that are covalently bonded. Now, you're not talking about covalent bonding here. It's not a bonding, it's just a mixture formed by heavy metals. It's not formed by heavy metals only. It can be anything. Now, from what I explained, can you tell me which one is going to be the answer between A and B?
Mixtures made up of metals and other substances.
Yes. So a compound, what's the difference between a compound and a mixture?
Naisha clear mix. A mix is a combination of two or more substances.
Okay, good. Now a compound is also a combination of two or more substances which are chemically combined chemically. So for example, sodium hydroxide plus hydrochloric acid, they form a compound. It is from a chemical reaction. Now, a mixture, there's no chemical reaction which happens. So the answer is A. For an alloy, you don't talk about chemical reactions. 16. Choose a fertilizer that contains all the three main elements needed by plants for normal growth. All the three elements needed by a plant for normal growth. Which one do you think?
Amaparanti yarafayika po nani bili pasi.
Okay, so for plant survival, they need nitrogen, potassium, and phosphorus. So which one is the answer here?
The potassium.
So the answer is C. That's the one which contains potassium, nitrogen, and phosphorus. Those are the essential elements. Young figure.
Yes.
17. A gas escaping from a pipe in a chemical plant is tested and found to be alkaline. What is this gas? So of these gases, which one is alkaline? You know an alkali?
Este ama group one elements.
An alkali is a base, just a base. An alkaline is a base that can dissolve in water. Unless if they say alkaline element, okay? But if you hear of alkaline, it's just a base that that has dissolved. So ammonia is a base. What of carbon dioxide? No. Hydrogen? No. Oxygen? No. So the answer is ammonia. Is that okay?
Yes, yes. So
Mm? Nayo mfika ka?
yes, sir.
Question 18. Some organic compounds are generally non-reactive due to lack of specific site of chemical attack. Which of the following is such a compound? Now, they are generally non-reactive. This word is what I want. So when you talk about non-reactive compounds, you basically refer to, you have got organic compounds. You can talk about alkanes, alkenes. At your level, you also talk about the alcohols and some bit of alkanoic acids or carboxylic acids and esters. But from here, we can use this. So, which one do you think among these is not reactive?
Wow. Our kings.
Alkenes have got a double bond. So, the double bond which they have can be broken. So, these are reactive. Alkenes have just a single bond. So alkanes are also called saturated, meaning they are unreactive. So what you want to see amongst this is an alkane because alkenes are unsaturated if the sugar. Okay, like if you make zigolo and then you have not added too much sugar, such you call it unsaturated because sugar typholisha you can add more. But saturated means the sugar is too much, even if you add more, it will not dissolve. So this one is reactive because it's an alkene. This one is reactive because it's an alcohol. It has got OH. This one is an alkene, which is also an alcohol. So it is reactive. But this one is not reactive because it's an alkane. Is that okay?
Yes.
Okay. Choose one organic compound that makes up 98% of natural gas. 98% of natural gas. Which one do you think makes up 98% of natural gas? You know natural gas.
No.
Okay. Natural gas is simply when you are talking about we have got what we call the crude oil. In other words, when you're talking about natural gas, you are just talking about alkanes. Yeah, you're talking about alkanes. So in this case, all these which are listed here are alkanes. Now, what's the difference? This one has got four carbons. This one, ethene, has got two carbons. This one has got only one carbon. This one has got three carbons. Okay. So the lightest, which is methane, is the one which makes up the most. Like when the carbons are few, it means that that gas is light. Yalianguka. So this one makes up the most of the compounds that make up natural gas, methane. So that will be followed by ethane and then propane and then butane. Is that all right?
Yes, yes. Mpaka mkamfunde kupata organic chemistry sana sana.
Okay. Okay, the last question here. Which of the following structures belongs to the same homologous series of compounds? Same homologous series. Now, if you're talking about homologous series, what you are saying is, are they alkanes, alkenes, or alcohols? So you can see this one here is an alkane because it has got only carbons and hydrogens. This one is not an alkane. And then this one down here is also an alkane. This one is an alkene. So 1 and 3 belongs to the same homologous series. So the answer is D.